So I'll discuss few more problems using using the properties of Laplace transform. I'll discuss few more problems in finding the Laplace transform using the properties. So in the first class, I have discussed the definition of Laplace transform, transform of standard functions. In the previous lecture, I have discussed the properties of Laplace transform. So we go for properties whenever you have to find the Laplace of the product. So I discussed two problems in the previous video. I am continuing with some more problems in this lecture. So here, so the third question, we have to find Laplace of e power 2t t cube. So you have to find the Laplace of the product. So whenever you have the product, see if you have an exponential term, you can go for shifting property. If you don't have exponential term, it will be any of these two types. You look into the product. If you have an exponential term, go for shifting property. Otherwise, it will fall into any of these two types, 12th or 13th. So here t cube e power 2t. So you can do this problem in two ways, either using shifting property or using the other one. So you have t cube e power 2t. So either you can find the Laplace using shifting property or you can find using this property. So I will discuss both. So Laplace of, so first I am discuss using shifting property. So you see the type, it is e power at form. What is the Laplace of f of t e power at, f of s minus a? So what is Laplace of t cube e power 2t? In place of a you have 2. So Laplace of t cube e power 2t is f of s minus 2. So we have to find f of s minus 2 through f of s. So what is f of s? L of f of t. What is f of t here? You compare this. F of t is t cube. What is L of t cube? You have integral powers of t. That is 3 cube by s power 3 plus 1. What is L of t cube? 3 factorial by s power 3 plus 1. So 3 factorial by s power 4. So f of s is 6 by s power 4. So if f of s is 6 by s power 4, you can find f of s minus 2. Just replace s by s minus 2. That is 6 by s minus 2 the whole power 4. So Laplace of t cube e power 2t is 6 by s minus 2 the whole power 4. Now we will discuss the same problem using transform of derivative. So what is the formula? Laplace of t power n f of t minus 1 whole power n fn of s. So here you have Laplace of t cube e power 2t. So t cube means n is 3. So minus 1 whole cube f3 of s. So take it as 1. We only f3 of s means you have to find the third derivative of f of s. So what is f of s? You have to get through f of s. What is f of s? L of f of t. What is f of t here? You compare with this. F of t is e power 2t. Say t power n, in place of t power n you have t cube. In place of f of t you have e power 2t. So f of s is L of f of t, that is L of e power 2t. What is Laplace of e power 2t? 1 by s minus 2. So f of s is 1 by s minus 2. So find the three derivatives. F dash of s is minus 1 by s minus 2 whole square. F double dash of s, the second derivative is minus 1 into minus 2 s min by s minus 2 whole cube. Third derivative minus 1, minus 2, minus 3 by s minus 2 the whole power 4. So we have got the third derivative. Substitute this in 1. So the right side of 1 is minus 1 whole cube is minus 1. And what is f3 of s? Minus 6 by s minus 2 whole power 4. So 6 by s minus 2 whole power 4. So we have the same answer using the shifting property as well as the transform of derivative. But if you have a choice, go for shifting property. You will find shifting property easier compared to using the transform of derivative, because the derivative sometimes finding the derivatives will take more time. So if you have the choice, whenever you have the product exponential with polynomial function, give priority, give preference for shifting property. It will because it saves time. Shifting property will save time compared to finding the transform using derivative. Now we have the second problem, t square cos a t. So t square, again you have to find the Laplace of the product t square cos a t. So you cannot use the first 10th and 11th because you don't have exponential term. So you have to use only the transform of derivative property, that is the 12th one. So Laplace of t power n f of t minus 1 whole power n fn of s. So if n is 2, Laplace of t square cos a t minus 1 whole square f double dash of s. So we have to find f double dash of s through f of s. So what is f of s? L of f of t. And what is f of t? Cos a t. L of cos a t. What is Laplace of cos a t? S by s square plus a square. F of s is s by s square plus a square. Now find the first two derivatives. F dash of s is find first derivative is by quotient rule you will get the first derivative as a square minus s square by s square plus a square the whole square. And second derivative again by quotient rule you will get this expression. I repeat, you have to find Laplace of t square cos a t. So here you cannot use the shifting property, you can make use of only the 12th one. So what is Laplace of t power n f of t? Minus 1 whole power n fn of s. So Laplace of t square cos a t minus 1 the whole square f double dash of s. So we have to find f double dash of s through f of s. So what is f of s? L of f of t. What is f of t? Cos a t. So what is Laplace of cos a t? Laplace of cos a t is a standard function, s by s square plus a square. So f of s is s square, s by s square plus a square. So f dash of s by quotient rule you will get it as derivative of s is 1. So 1 into the denominator s square plus a square minus the derivative of denominator 2s into s by the denominator whole square. F dash of s is a square minus s square by s square plus a square the whole square. Then again differentiate with respect to s. You by quotient rule derivative of numerator minus 2s into the denominator s square plus a square the whole square minus derivative of denominator 2 times s square plus a square. And what is the derivative of s square? 2s into the numerator by the denominator whole square, that is s square plus a square the whole power 4. So in the numerator minus 2s into s square plus a square is common. So the first term is s square plus a square plus 2 times a square minus s square. So if you simplify, you will get minus 2s into 3a square minus s square by s square plus a square the whole cube. Now we have the next problem, t e power minus 2t sin t. So here you have to find Laplace of the product of three terms. Here you have to find Laplace of product of three terms. You have both exponential and polynomial function. So first we will, whenever you have to find Laplace of product of three terms where you have both exponential and polynomial, first use shifting property. So what is shifting property? L of e power minus at f of t is f of s plus e. So L of e power minus 2t t sin t. What is f of t here? T sin t. And what is a here? What is the coefficient of t in the exponential term? 2. So f of s plus 2. So Laplace of e power minus 2t t sin t is f of s plus 2. And we have to get f of s plus 2 through f of s. What is f of s? L of f of t. What is f of t? T sin t. So what is Laplace of t sin t? So it is minus 1 into f dash of s. What is Laplace of t sin t? Minus 1 into f dash of s. So n is 1, so you have minus 1 into f dash of s. So we have to find f dash of s through f of s. So what is f of s here? L of f of t. What is f of t here with respect to 2 sin t? What is Laplace of sin t? 1 by s square plus 1. So f of s is 1 by s square plus 1. F dash of s, the first derivative is minus 2s by s square plus 1 the whole square. So we have f of s as, what is 2 now? F of s as minus 1 into minus 2s by s square plus 1 the whole square, or 2s by s square plus 1 the whole square. So we have got 2. So we have to get 1. Right side of 1 is the answer for us. So what is f of s? 2s by s square plus 1 the whole square. So what is f of s plus 2? Just replace s by s plus 2. So you will get 2 times s plus 2 by s plus 2 whole square plus 1 the whole square. I repeat, whenever you have to find Laplace of product of 3 terms where you have both exponential and polynomial, use the shifting property first. So you have e power minus at. So what is Laplace of e power minus at f of t? F of s plus a. So Laplace of e power minus 2t t sin t, f of s plus 2. So f of s plus 2 is a solution for us. So we have to get f of s plus 2 through f of s. So what is f of s? L of f of t. What is f of t here? T sin t. So what is L of t sin t? It is minus 1 into f dash of s. So minus 1 into f dash of s. What is f? We have to get f dash of s through f of s. F of s is L of f of t. And what is f of t here? Sin t. L of sin t. 1 by s square plus 1. F of s is 1 by s square plus 1. So what is f dash of s? By quotient rule it is minus 2s by s square plus 1 the whole square. So what is the right side of 2? What is the equation 2? F of s equals minus 1 into minus 2s by s square plus 1 the whole square. So that is 2s by s square plus 1 the whole square. Now what is the answer for us? F of s plus 2. So if f of s is 2s by s square plus 1 the whole square, f of s plus 2, you just have to replace s by s plus 2. That's what we have here. Now the next problem, sin a t by t. So I have taken a problem using the 13th one, f of t by t. It is of the form f of t by t. What is L of f of t by t? Integral s to infinity f of s ds. So this is a property. So what is L of sin a t by t? Integral s to infinity. What is f of s? L of f of t. What is f of t? The numerator, that is sin a t. So L integral s to infinity L of sin a t ds. So what is L of sin a t? Laplace of sin a t, standard function, a by s square plus a square. So integral s to infinity a by s square plus a square ds. What is it? Tan inverse of s by a from s to infinity. When s takes the upper limit infinity, so tan inverse infinity is pi by 2. When x takes a lower limit s, tan inverse of s by a. So pi by 2 minus tan inverse of s by a is cot inverse of s by a. So I repeat, whenever you have f of t by t form, make use of the 13th one, that is L of f of t by t integral s to infinity f of s ds. So what is f of s here? L of f of t. What is f of t here? Sin a t. So L of sin a t. What is L of sin a t? A by s square plus a square. So what is integral s to infinity a by s square plus a square ds, tan inverse of s by a from s to infinity. So when s takes the upper limit infinity, tan inverse infinity is pi by 2. When s takes a lower limit s, tan inverse of s by a. So pi by 2 minus tan inverse of s by a is cot inverse of s by a. Now similarly, cos a t minus cos b t by t. So this is also of the same type. So make use of the property L of f of t by t integral s to infinity f of s ds. So what is f of s? L of f of t. What is f of t? L of cos a t minus cos b t, that is split into two, L of cos a t minus L of cos b t ds. What is Laplace of cos a t? S by s square plus a square. What is Laplace of cos b t? S by s square plus b square. So integral s to infinity s by s square plus a square minus s by s square plus b square ds. So this integral is same as half log of s square plus a square, and this integral is same as half log of s square plus b square from s to infinity. So whenever you have log of a by b, where where the upper limit is infinity, you ignore the upper limit. I repeat, log a minus log b is log of a by b. Whenever you have log of a by b where the upper limit is infinity, ignore the upper limit because it will tend to 0. You don't have to give the reason. It is understood that log of a by b for the upper limit infinity is 0. So ignore the upper limit. For the lower limit, it will be minus half log of s square plus a square by s square plus b square, or it is same as half log of s square plus b square by s square plus a square. Now we have another problem. Evaluate integral 0 to infinity e power minus t sin t by t dt using Laplace transform. So this is also of the form f of t by t, but this is slightly different from the previous two problems. So whenever you have, see the first two questions, you were asked to find Laplace of f of t by t. So here you have to find Laplace, you are asked to evaluate the integral using Laplace transform. See, in the first two problems, you are asked to find Laplace of f of t by t. But here you are asked to evaluate the integral. Whenever you are asked to evaluate the integral, replace t by st. So how do you get this integral? It is by taking s as 1. So it is same as Laplace of sin t by t. I repeat, whenever you have to evaluate the integral using Laplace transform, in the exponential term, replace t by st. Whatever you have. Suppose if you have 2t, replace 2t by st. You have 1t here, so we are replacing 1t by st. So it is, the given integral is same as this integral at s equals 1. Now this integral is nothing but Laplace of sin t by t. So this integral is nothing but definition of Laplace transform, that is Laplace of sin t by t at s equals 1. So you know to find Laplace of f of t by t. What is Laplace of f of t by t? Integral s to infinity f of s ds. What is f of s? L of f of t. What is f of t? Sin t. So integral s to infinity Laplace of sin t ds. What is Laplace of sin t? 1 by s square plus 1 ds. What is integral 1 by s square plus 1? Tan inverse of s from s to infinity. So when for the upper limit it is pi by 2, tan inverse infinity is pi by 2. For the lower limit, tan inverse s. So pi by 2 minus tan inverse is cot inverse s. So Laplace of sin t by t is cot inverse s, but you have to find that s equals 1. So take s as 1. So cot inverse of 1 is pi by 4. So one of the use of Laplace transform is to evaluate the integral. So that's what we have here. So we will discuss some more problems in evaluating the integral in the next class. With this I end my lecture.